Welcome back to Data Science Pursuit. This video summarizes the key takeaways from the past three videos, which are now part of our Introduction to Data Science course playlist. And you can find the link to that in the description box. All right, let's begin. So, data science is a field that focuses on extracting valuable knowledge and insight from data to solve different problems. Data scientists can do this using a combination of domain or business knowledge, math, computer science, and they also need good communication skills. An example of an application of data science is employee retention analysis. We will use this example to explain the data science lifecycle, that is, the steps that data scientists take when solving a problem. The first step is problem definition. This is when the data scientist works with their customers to understand the business problem and define clear project goals. Domain expertise and curiosity can help data scientists avoid answering the wrong question. So there are four main types of problems that data scientists can solve. First is what's called descriptive analytics, where the data scientist can tell what happened in the past. Second is diagnostic analytics, where the data scientist can explain why something happened. Thirdly, predictive analytics, where the data scientist can predict future outcomes. And then lastly, prescriptive analytics, where the data scientist can advise the best course of action for the predicted outcomes. So these four analytics build on each other and they increase in complexity. So in our example, problem definition would involve determining what company X is mainly interested in. Do they want to know their current or past retention levels, or maybe what causes employee turnover in their company? Do they instead want to predict turnover or get recommendations on how they could retain the employees? The data scientists will also ask where they can get the data to do the analysis, which leads us to the next step. Data acquisition. In data acquisition, the data scientists collect the data that they need to solve the problem. So for our example, this may include things like employee details, like demographics, job titles, department, years of service, performance scores, salary, engagement survey responses, and maybe exit interview data. Additionally, we may consider gathering external data such as industry benchmarks, like what's the industry salary for those jobs, or economic indicators that may be relevant to the analysis. The next step is exploratory data analysis and data cleaning. In this step, the data scientists analyze the data to identify and resolve data quality issues, and they also find preliminary patterns. So cleaning involves addressing data quality issues that most real-world data has, for example, duplicates and missing values. Cleaning the data will give you the best results. So in our example, we can start off by finding data quality issues and cleaning the data, and then we would calculate the overall retention score for the company and its different departments, and then explore insights. For instance, we may discover that certain departments have higher turnover rates than others, so this step provides descriptive analytics, i.e., it's giving us a clear picture of employee retention. And if necessary, we then proceed to more advanced analytics in the next step. During modeling, we train or build machine learning models that can diagnose problems, make predictions, and prescribe the best next steps, i.e., the three advanced analytics that we talked about previously. So for this company, models could tell us why the company or different departments have been losing or keeping employees. It can also predict the future retention rates and determine what the company could do to improve employee retention. Once we have our insights, we share them in the next step, visualization and presentation. So the data scientists present findings or recommendation in a way that the customer can understand. Effective communication will help the company make use of the findings. And then the last step is deployment, where the data scientists or their customer implement the model or recommendations and monitor outcomes. So in our example, there are a couple of things that could be done. Firstly, reports and dashboards could be created to monitor retention, or a predictive model may be implemented to predict if any future employees are likely to leave or stay. And based on the insights gained, the company may also implement the prescribed strategies to increase retention. So this could involve something like adjusting compensation and benefits or improving safety and work-life balance. And also that's left now is to monitor to see if the analysis needs to be redone. Please note that larger teams or organizations may have more specialized roles. Data scientists may only perform certain steps in the data science lifecycle. For example, data engineers can do the data extraction and cleaning, and business insight analysts can help define the problem and interpret the results. Lastly, when working with large amounts of data, most of these steps are optimally done using programming. Data scientists most commonly use Python and R programming languages. For beginners, we advise you to focus on learning one programming language. Once you learn one, it will be easy for you to learn the other language later if needed. So wait, now that we say that, maybe it'll be a good idea to provide an R versus Python video for those who are unsure which one to start with. So yeah, I guess that will be our next video. See you then.